Good morning. Welcome to Physics Studio. Today we're going to begin studying a different kind of motion called periodic motion. And periodic motion is basically motion that repeats itself over and over again in some kind of a semi-regular pattern. Periodic motion is surprisingly common in nature. And we're going to find periodic motion occurring from the subatomic level to the level of galaxies and even the universe. So what we want to do today is we're going to differentiate periodic motion from the kinds of motion we've studied. And then we're going to put into place a couple of technical terms to quantify. So let's begin. Okay, so first, we need to differentiate. Well, we should say that if you put matter and energy together, you get motion, right? And we've studied two types of motion so far. First type is called linear motion. And the second type is called circular motion, right? Now we want to define these again, just recall to mind, and then distinguish them from the kind of motion we're going to study now. Now linear motion is motion that goes from point A to point B, where A and B are different. And you might think of linear motion as being in a straight line. That's a particular thing called rectilinear motion. But linear motion more generally just goes from point A to point B. And there's a couple of variables that we have to define that. And we know that in defining this, we think about displacement, velocity, acceleration, and there's time, force, etc. Now in circular motion, that's motion that travels around, goes from point A to point B, where point B is the same as point A. A and B are the same. And it's further specified by being a certain equal distance from a point, which we call the center. So that's circular motion, and we have a few other quantities that we think about with circular motion. One is radius and centripetal force. And we still have velocity, and of course mass figures into each of these. So these are two types of motion. Now, the type of motion we're going to study today is called periodic motion, and that's motion that repeats itself over and over again. In other words, it goes through some kind of process. Of any particular complexity, starting at point A, going like this and whatever. Then, because it repeats itself though, it ends back up at point A. In other words, where A and B are equal to each other. And then it just goes through the cycle again. Now you can see from this that circular motion is a certain kind of periodic motion, a very regular kind. Now, when we're talking about periodic motion, the first thing we have to be able to define is the cycle. Right, and the cycle is what repeats itself. It's what's done over and over again, going from A through the process to B. So a cycle is a process that goes from point A and eventually returns to point A and repeats. Well, it doesn't repeat. Okay, so that's the cycle. It goes from point A to point A. Then the cycle then is what repeats itself. Now, we have to define a second term. And let's say here it returns to its starting point. And so we can think about the cycle of the seasons, right? You start in the spring, you go through this whole cycle where you go through summer, fall, winter, and then you eventually get back to spring. Okay, that's the cycle that repeats itself over and over in the cycle of the seasons. Now, the system then. We're going to have to define a system. That's what repeats the cycle. And so if we thought about the cycle of the seasons, what would be the system? You know, it's something we have to define. Now, it's obviously going to include whatever environmental factors are at play in the part of the Earth that you're at, but you also have to include the input from the sun and the changing geometry of the Earth's orientation of the sun as it goes around it through its revolution. Do we have to include the stars? No, they don't really contribute to the seasons, though they follow along. Now, so cycle is a process that goes from a certain starting point, goes through a process, and then returns to the starting point. System is what repeats the cycle, and it's just you define all the things that factor into that periodic cycle. Now, let's consider an example. You all have seen you have been on a swing, you've seen children on swings, right? And they go through periodic motion, right? They go through a process that repeats itself over and over and over again. Now, what sorts of things? First of all, how would we define the cycle, and what is the system? So if we're talking about the system, okay, we would have to have some kind of a pivot point, and then a chain or a rope, and then we would have to have the child. Right, and the child we could generalize as the mass, okay? And we have some kind of a rope or chain, and we have a pivot point here. We also have to say, okay, when the child gets up to here, what pulls them down is gravity. And so we might want to include the Earth in the system. So the system for this would be the mass or the child, a rope or chain, a pivot point, gravity. And you might also want to say, well, you know, you have to have an older sibling or a parent to push at first, right? So something to set it in motion. And once you have that done, you might want to say, well, you know, you need a frame, you know, you need some kind of frame to hang the pivot point on, which would be a swing set, etc. But once that's set in motion, that child is going to start swinging, right? Back and forth, repeating the same motion over and over again. That's periodic motion. Now, would we want to include the parent watching from the kitchen window in here? Maybe, maybe not. It's really not necessary. Are we going to include the neighbor down the street? No, it's not necessary. It's not part of the system. So you define the system as the things that contribute to the periodic motion. And so this child is going to go from here, starting point A, through a cycle, and back to A again. Now, that brings up the question, how do we identify a cycle? And to identify the cycle, you simply observe the system repeating, right? And you choose a starting point anywhere. So let's say we choose here as our starting point. you'll observe the system, right? The child goes out here. Then they swing back again, and when they reach back to the starting point, you've defined a cycle. If you think about your heart rate, right, it goes something like this. You would observe that system, right? And pick a starting point, say the peak right here. You would observe the system till it returns to that starting point. And that would be one cycle for a heartbeat. And you can do that for anything. If we thought about the seasons, right, you might think that the cycle for the seasons is the 3-month season. But really, to return to the starting point in spring, say, when the leaves are just starting to come out of the trees, you would observe and go through summer, through fall, where the leaves drop, through winter, where it's fallow, and then back to spring. So the starting point we'd be back to the starting point, and the cycle is 1 year. Now, this brings up our two quantities that we need to define this motion, which are different from what we've had before, though you've run into them. Okay, quantity number one is called the period. And the period is a time for one cycle. And we represent period as tau. That's the Greek letter T for tau. And tau equals the number of cycles divided by the time. And so, for example, if we observed something to go through 5 cycles in 10 seconds, I'm sorry, erase that. It's the time for a cycle. So effectively, to find that, we would observe the thing and say we saw it took 10 seconds to go through 5 cycles, then the period would be 2 seconds. Technically 2 seconds per cycle, but we'll typically just say 2 seconds. So the general formula for period is the time divided by the number of cycles. Now we have a second, which we call frequency. And frequency is the number of cycles per unit time. And we write that frequency small f equals number of cycles per unit time. And we can see that the units for that are cycles per second. I mean, it could be cycles per week, cycles per year, whatever you choose. But cycles per second is the particular unit, which we call the hertz. So 1 hertz equals 1 cycle per second. Now in our example over here, the frequency would equal 5 cycles in 10 seconds equals 0.5 hertz. And that's your basics on periodic motion. What we're going to look into tomorrow is why periodic motion is so common in nature. And it's kind of interesting. But for now, just get used to the mathematical relations. And you should notice that there's a relation between period and frequency that's very simple. And I'll let you derive that and get that from your book. So anyway, let's start thinking about cycles. I want you to observe periodic motion around you and do a couple of problems, and we will see you tomorrow. Good luck.